When you apply substitution to an integral, you get a simpler integral. It might not be simple enough to finish the problem right now. So what might happen is you might need a second substitution. And that's what we'll see in section 3.2.4. We'll see double substitution, where you need to do a substitution and then a second one. So you may need to apply substitution twice in an integral. All right, so let's try example 3.2.6. Problem A, I have cosine of x times ln of sine of x times sine of x. There's a lot. There's a lot. I have sine of x inside the log, and I have sine of x inside the denominator. And then its derivative, cosine of x, is here. So I'm going to take u equals sine of x. du is going to be cos of x dx. So the du will eat up the cos of x and the dx. And so what I'll have is I'll be left with ln of sine of x, which is ln of u. Sine of x in the denominator becomes u, and then everything that I've written in green is going to be du. All right, this is better, it's simpler, but it's not a basic integral, and it's not something that I could, from which I could reach a basic integral using algebra. So I have kind of a bit stuck. Probably need to do integrals substitution again if I look at the title. So I need to look for a second substitution. The only thing I have inside another is u, but we said if you do that, you're just relabeling the variable. It's useless. I have another u, that's useless too. Now one thing I noticed though is that 1 over u du, that's the derivative of log. So what if I take, you need a different letter, so let's take z. Now whatever you've used here, you need a second letter. I like y, z, whatever you like. V works as well. I'm going to take z to be ln of u. Then dz is going to be 1 over u du. And so that 1 over u du, that's going to take care of this and this. And so I'll be left with just z dz. Now that's a nice integral. That's one that I can compute. It's z to the 1, so I get z squared over 2 plus c. And now I want to go back so that my final answer is in terms of my original variable, which is x. So if I have z, I could write z as ln of u. So I'm going to get ln of u squared over 2 plus c. And then I want to go back to z. And so I'm going to replace, go back to x. So I'm going to replace u by ln of z. So I'm going to get ln of sine of x, all of that squared divided by 2 plus c. And that's it. Right? So I'll do the next problem in the next video.